Okay. Hi everyone. My name is PY. Well, my name is Pierre, but people call me PY or Pierre. My parents did not call me PY. Sorry, that's not my name. Anyway, so let's try again. My name's Pierre. People call me PY or Pierre. I work at Square, or rather at Block, which used to be named Square. But it's still named Square in a way, but it's also named Block. It's a complicated story. It's a bit like Facebook and Meta and all those kind of renaming stories. And I have a Twitter where I like to say random things. So if you're interested. So today we're going to talk about the performance of Android apps. And I don't know, a couple months back, I came up with this acronym that I found funny, which was PAPA, Performance of Android Production Applications. And because I've also done that as of the last 3 years, and this is our second kid, my daughter, playing with systems performance, a huge book. It's a really good book, but I've only read some parts of it. It's been more useful as a toy for our so for the past 3 years, I'm focusing on app performance and trying to learn about it because we had some issues and we were like trying to be better about that. And so I thought I would buy this book, which, well, that doesn't work. So no clicker, it's fine. This book, the definitive guide on everything performance from Romangi and Chet has, which unfortunately does not exist. You can't look it up. It's not a thing. So I was like, okay, I couldn't find a book about app performance. So I thought I'm gonna start to watch tech talks, read some blogs, and learn a bunch of things. So what did I learn by reading online resources? I learned about common causes for performance issues, such as, oh, you shouldn't be doing I/O on the main thread. Don't read the disk on the main thread. Oh, if you run out of memory, then you're going to have issues like the GC is running. Oh, you should fix your memories. You may know that I happen to be the author of Leak Canary, a library from Square to detect memory leaks. So it's very much my domain. But it's only one of the possible causes for perf issues, right? Or your hierarchy is too complex. Or you should stop creating objects. Some people say, yeah, don't create objects because it's too expensive to garbage collect. Or you should stop using enums. Enums are slow. Luckily, that was a discourse that was happening, let's say 5-6 years back, and it's kind of stopped. People don't say this anymore. That was one of the common causes that that people would talk about. And common cause for perf issue, it's like when you read all of this, it just means the developers are doing dumb mistakes. So the common cause is really the person writing the code, right? And that's how I interpret those things. They're when you see everything, when you see all this advice, it's really telling you stop making mistakes. And like, that's cool. Yeah, we should stop making mistakes that are introducing performance issues. But we write apps as part of teams where there are a bunch of people working together, and usually people don't intentionally do something, and usually just telling people don't do I/O on the main thread is not going to be enough for fixing your performance issues. Now, if you look on the internet for common fixes for performance issues, you'll see stuff like fix the memory leaks, or use constraint layout, or actually use compose, or use both at the same time. Use Dagger, not Coin, because like Dagger is compile time and Coin does some runtime stuff and blah, 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 blah. I'm not going to enter that debate right now. Of course, use Dagger. Just kidding. Enable, all right, it's going to minify your code. It's going to remove all the useless code you don't need. Use the Android X startup library because you're going to have less content providers, and somehow that's going to be faster and change everything about your startup. Write macro benchmark tests because it's going to tell you how slow your startup is, and so it's going to be faster. You want to make it faster. Enable baseline profiles because that way I could do a whole talk, right? We could do a whole talk about baseline profiles and how they make compilation. I don't think I want to get into that, but basically, baseline profiles are great. Or you could also rewrite the app in C, because we all know C is really fast, right? So you have all this advice that you find online, and let's say you do all of this, maybe even rewriting the app in C. Does it mean your app will be faster? Does it mean that your performance problems are going to be solved? Not really, but like maybe, but probably not, because these things are important and you should probably do them. They're like very generic type of device that apply to everybody and really no one at the same time. So why do we have this type, why do we have content about the common causes and the common fixes? Because the whole problem about app performance today, as you again, you work in teams with a lot of people collaborating, the whole problem is that every problem is specific to your application, your code base, and the latest set of changes you've done, and how different your app is. So it's really, really hard to come up with generic advice that actually applies well to your case. I would say it's impossible, so it's what I'm going to try to do today. I'm going to try to stay away from best practices. I actually think best practices are the worst. They can be useful, but it tends to lead to people focusing on the wrong things instead of the actual problems that you're facing. So we're going to try to look at some practical advice. I don't know that I'm going to succeed, but I'm going to try anyway. So where do we start when it comes to performance? If we don't look at, yeah, it's dark, it's supposed to be blue, dark blue, but everything's fine with the screen, thanks. So where do we start when it comes to performance? Like, do we start thinking about memory, CPU? None of this. We start with people. We have this saying at Square, it's like people first. It's a bit cheesy, but it's like, oh, always think about people first. And so we build applications for humans, right? Like phones are used by humans. And the performance of an application, it directly affects their experience and their life. And so when we're improving performance, we're actually improving user experience. That's the entire reason. Like on the server side, you could say I'm improving performance, it's going to be cheaper, we're going to save some money. We're not doing that on our phones, on our application. We're trying to improve user experience. So it's user-centric performance. And it's the only thing that matters. And the thing is, if you think about that level, there's really just one typical problem, maybe two performance problems that you run into. And to talk about that, we need to talk about how humans work. So you all have a brain, right? And you're using a phone, right? And so your brain tells you, I'm going to tap on this button. So you go and you like activate your muscles and tap on the button, and you tap on the screen. And then the little computer in your hand decides it's time to update the UI, updates the UI, and that updates the display. And then, at the speed of light, the light goes into your eyes, or I guess your eyes captures the light. It's not like the phone is directly directing light at your eyes. And your eyes, they catch that signal, and then they send electric signals to your brain, and your brain's like, oh, okay, I touched the screen, something happened, And so when we talk about performance, we're really talking about this loop here where I did something, oh, something happened. And luckily for us, our brains are pretty fast. Light travels pretty fast. And so the slow part here, and even our muscles are somewhat fast, usually. So the thing that's slow here is what happens inside the phone. And that's where performance matters, right? So the word that I like to use, the kind of like words that I use to describe this is interaction latency. So we're interacting with the device. And there's a latency between, if we kind of simplify, I touch the screen, the display updated. And so, we can start thinking about, okay, there's a latency, right? And it takes time, right? Like what's good? How much time is good? How much time is like too slow? And how much time is fast enough? So that's actually kind of contextual. So if you're if you're starting an app on your phone, right? Any idea how long you kind of expect it for it to take? Like today you take your phone, your latest Android phone, you're like starting it. How long is fast enough, and how long is like, hell no, I'll just kill that app? Any takers, any suggestion?
10 milliseconds?
10 milliseconds. Nice. I wish my app started in 10 milliseconds. Yeah, so that's an interesting suggestion. Absolutely not. So if you look at the Play Store, they'll tell you like, oh, your app should have a cold start of less than 5 seconds, otherwise it's horrible. But a fast, a hot start of like 1.5 second and a warm start of like 2 seconds, and you're like, the users, they don't really care about is it a hot start or warm start. Like, what do you mean? The only difference is usually hot and warm start. They came to the app recently, and they're probably coming back through recents. So what's going on with these thresholds of like 5 seconds, 1 second, whatever, is that they're contextual. We're creators of habits, and we're used to most apps taking a couple of seconds when we launch them on the launcher, and we're used to apps resuming really fast when we launch them from recents. And that habit that we have today is different from the one we had 5 years ago with different devices. And in 5 years, the expectations are going to move, and we're going to expect things to move faster. So there's a difference between what we perceive and how fast we can perceive things and what we judge acceptable. And that means that performance targets are like a moving goalpost. So you always need to kind of figure out what's everybody else doing, and you need to be better than that. But in 10 years from now, we're not going to talk about the same numbers. When it comes to clicking a link, in-app navigation, clicking a button, that kind of thing, the current recommendations are less than 200 milliseconds. It's fine. Don't worry about it. More than 500, you need to fix it. And in between, it depends. If you can fix it, it's great, but it depends on how important that is. And so when it comes to the actual human body and abilities, there's been studies showing that you cannot actually distinguish any change under 69 milliseconds. So if you were able to hit 69 milliseconds for a reaction, an interaction, you wouldn't need to improve it any more than that. But really today we're saying 200 is fine. This is from web.dev/INP, and this is like I think the Google Chrome team put this together. It's an amazing website. The web dev teams are so much ahead in terms of like performance and user-centric performance, and we are in the mobile world. So there's a lot to borrow there. So I just said 200 milliseconds, and you were suggesting I think 20 milliseconds. So who's heard about the idea that screens refresh at like 60 frames per second, and we have 16 milliseconds to render every frame? Is that something that rings a bell? A few people maybe in the room. So I just said 200, but we have this rule of like every 16 milliseconds you need to render. What's that about? Well, it's about motion. When things move, our brains have different expectations. So we have this thing where our eyes just see like screenshots over time when something's moving, and then our brain is turning that into an actual movement. And so the same thing happened on the screen. So we have these expectations that when it comes to motion, so when it comes to interaction, I'm tapping something, I expect an action from the system, 200 milliseconds is great. When it comes to motion, we don't really think actively about it. Our brain is just putting it all together, and there's no intent behind that. You need to basically hit every frame because the displays today are actually too slow. Like I think the ideal, that the minimum time for you to detect things is 11 milliseconds. And at 60 frames per second, we are actually at a greater than that threshold. So in a couple of years from now, we'll probably have displays that are fast enough, and then we may be able to relax and not hit every frame. But today, if you want consistency, so you need to hit every frame. So let's look at an example of how lag is perceived. So here, I'm tapping on the button, there's no lag. Then I'm tapping on a button with 100 milliseconds of lag, and you're barely going to notice it. Then I'm going to do 300 milliseconds, and you're actually going to see the difference. You can feel it, right? You can immediately feel it. If I do 700, you're going to hate it. You're like, it's horrible. I'm going to kill this app immediately. Something wrong. Let's restart it. So then I'm doing the same with like a drag thing where I'm but it's a much smaller amount. But you can notice how when I'm dragging and there's motion, I actually feel we're under 100 milliseconds of lag here, but it feels it feels bad because of like that motion element. So that kind of tells you when you're dealing with motion, animation, drag, that kind of stuff, you need to hit every frame. Then, of course, one of the important things is thinking about your use case. I work at Square, we do a point of sale, and so our goal for ourselves is everything that people do a lot is cashiers. They just keep typing items, typing on the screen, right? Everything that you do a lot should be fast enough, and nothing should be horribly slow. And then the stuff that you occasionally do, they can be a little bit slow. It's not the most important thing. Another thing for us is people start the app at the beginning of the day. It stays on all day. They never start it again. So app startup, it's fine. If it's a bit slow, right? It happened once. We will forget about it. So it's not our priority. But critical interaction is like muscle memory. It needs to be fast. So yeah. So generally, to summarize, people first. You need to think for yourself what's important in your app. The parts that are important, if motion and scrolling, if you're doing video, obviously, or if you're doing a Twitter feed, you want scrolling to be fast. But what's important for you? And then the thresholds are contextual, so really depends app startup and all that. That's why you'll see different values. But when it comes to motion, you do have to aim for every frame. So how do we fix performance issues? Who here wakes up in the morning, opens the IDE, and randomly fixes like what looks like bad code that's a bad performance problem? You don't do that. I mean, sometimes maybe you do, but generally you don't just look at code and be like, that's wrong. There's a huge performance problem. I just know it by looking at the code. I'm going to do that. That's going to be 2 days. That's what I'm going to do. Usually, sometimes you may, but usually what happens is you discover there's a problem and you fix it. So what's important here is discovering issues. So how do you fix it? Do you just set fast equals true and then it's fixed? Probably not, right? So what do? You investigate to understand what's going on. And this is actually really hard because you need a lot of data. So how do you make investigations really easy? How do you make sure that you always solve the problem? You reproduce. If you are able to reproduce a problem, you're going to be able to keep, debugging, profiling, investigating it really deep. As long as you can reproduce, you can understand it. If you can understand it, you can fix it. Also, you can verify that you fix it because you've been able to reproduce it. So how do you reproduce? Well, you need to, ask a bunch of questions like what's the scenario, what's the device, what's the account, that kind of stuff. And then once we're fixed, are we done? We're not done. We need to write a test for it, like every bug fix. And that's basically the idea that maybe we want to prevent it from happening again. And you can also go meta and think, okay, why is this bug happening? Do we have a problem in our code base where we keep making the same mistake? And then try to find the actual root cause of why the mistake keeps happening. If you look at these letters in order, discover, reproduce, investigate, fix, and test, that's DRIFT. A nice acronym. I like acronyms. So let's dive into this. Information gathering, which is the part where you're looking for information, it really has 3 goals. And it's important to remember these 3 goals: discovering, reproducing, and understanding the root cause. And it's important to talk about that because you're not, depending on what you're doing for gathering information, you're going to serve some goals, but not some other goals. So we typically talk about feedback loops, where I'm trying to fix something and I introduce a change, and then I have a feedback loop that tells me it's broken. So there are different kinds of feedback loops. So you may have QA at your company, a bunch of people testing the app, right? And you might ask them to do performance test, right? So the thing with QA, it's expensive because you're paying people to manually do stuff. And you need to give them clear priorities, otherwise it's just going to be, spending all that money on the wrong things, like testing the wrong thing. The thing with QA too is you don't know whether good QA, kind of finds problems, but you have no idea how much they're going to find and if they're going to find all of the problems. The thing about good QA too, though, is it's usually they're really good at telling you the steps that they followed to create the problem. So it helps with reproducing. But they won't tell you why it's happening, and that's fine because you can reproduce. So once you can reproduce, you can find why it's happening. An alternative to that, which we've been doing, is having a team set up a testing party. I don't know if you've heard that term. We used to call that testing parties because at the time we would do it at 4 p.m. and bring beers, and it was like, it's a party, we're testing the app, which is not really a party, but trying to make it fun. Anyway, the point is that that you get together with your PM and designers and like everybody in the team, and you try to break the app, maybe from a performance standpoint. Other type of feedback loop, compile time, lint checks. So lint checks, they're very, very noisy. They make a lot of noise. They're going to tell you something wrong, and you're like, I don't know, I think it's right. But also, they find really stupid or common mistakes, maybe something you didn't know. But they're not really going to find the highly complex performance issues. The good thing about lint checks is that they're immediate. Of course, you can immediately reproduce the problem. It's right there in your IDE. The root cause is I wrote this line of code and it's telling me that I shouldn't write it. So it's like immediate. So it's really fast in terms of feedback loop, but the signal is just not that interesting. CI is great, but performance tests can be super flaky in CI, and that's a problem because then you start paying attention. But if you do introduce a change and you have a good CI, then you're going to be able to reproduce the issue. And usually, because the change is tied to the failure, you can actually fix it. So the thing with CI is also it can be slow, and so your engineers are maybe waiting more time for the performance test to finish. Now there's another feedback loop, and that one is really nice because it's free, and we all get it. If you go on the Play Store, you can go in a section called Android Vitals and get a bunch of performance data for your application. And that is really cool. Now, the problem with that is it doesn't cover all that much. It tells you startup data, and it gives you like how long it took for your app to take as an aggregate. And it tells you stuff like ANRs, like when the app is frozen. There's some data around frozen frames, but it's not really that useful. The biggest problem with Android Vital, so this is like production data. So it's what's happening to your customers, which is amazing. The problem with that is they're, obviously they don't want to give you anonymized data. They don't want to tell you who's having problems. They're trying to protect the privacy of the customers. And also you have to opt in. So it's not everybody. You're going to not get data on everybody. You only get data on people who opt in. So you only get aggregates, which means it's really hard to know, like, unless everything is slow for everybody, it's really hard to know why this person, why a subset of users are having a slow startup. So it's like it doesn't cover much ground, and you can't really do much about it. You're like, okay, startup is slow sometimes. I guess I'm gonna try to start the app, see what happens. And so you can't understand the root cause either. But it's free, so it's a great way to start having a conversation with the rest of the company about how we should invest in performance. It's like, look, we got a bad grade here, and look at how our competition has better grades than us. We should do something about it because it's going to be really bad for our ranking in the Play Store. That you can make that up. It's fine. It's going to help convince people that you should do it. So the thing that we do that I highly recommend is custom production perf analytics. So you can write code that logs to your analytics solution your performance information. The good thing about that is you can still respect privacy, but you can add a lot of additional context that's going to help you with understanding, like, oh well, they went to this screen and that screen and this screen, and they were on this specific type of device and these other things, and you can start seeing attributes of and start grouping. All right, there's a group of people having a hard time, and these are the common attributes that they have. It doesn't help you with understanding the root cause, but it really helps with reproducing because now you have additional context. So once you can reproduce, you can fix. So I would start there, actually. I wouldn't start with UI test or perf test. I wouldn't start with Lint. I would really start with, all right, I would start with Android Vitals because it's cheap, it's immediate, and then go to, let's add the right logs so that we can track what's going on in the app and track the exact metrics that matter for our application. Now, the next step, though, and that's something that few companies do, is production tracing. I think Facebook does that, maybe Uber, a bunch of others, where you're actually capturing a lot of technical information about the code that's executing in production for like a subset of users, a very small subset. And so this is not the same as capturing metrics and analytics. And usually it's so much data that if you just looked at that data, you wouldn't be able to say, oh, there's a problem or there's no problem. But once you've identified a problematic area, and if you're not able to reproduce it, it's nice to be able to say, all right, for the people who have that problem, I can look at production data and get some more hints about what's going on. And maybe it's low memory. Maybe I can see that they're invoking this part of the code, and that's slow. This is really expensive to build. So either you can find third-party solutions that do an okay or really bad job at it, depending on. I'm not going to name any names, but so it's really expensive to build. So let's talk a bit about the custom side of things. So how do you measure application startup? So this is a naive implementation where we're essentially saying, oh, in my application class, when I get on create, I'm going to capture a timestamp. And then when the first activity is created, I'm going to capture a timestamp. I'm going to do difference, and that's the time it took for the application to start. And that's a total lie, and you're missing a lot of data here. So first of all, an application can be started in background for like a service or something. You don't really have control over that. So the first activity, the process might have been started like hours ago. But ignoring this is the actual, so here, this is a Perfetto trace. I'll get to Perfetto in a bit. But this brown area is what gets reported to the Play Store. And so you can see this long brown area. Then let's zoom in. So you see three rows here. The first one is just the metric. The second one is the main thread, and the third one is the render thread. I'll get to that in a sec. So if we zoom in, you can see on the right-hand side, by an application, this is where your code and resources are loaded. It's even before application on create. It's like loading the code, loading the resources, creating the application instance, and calling on create. So before that, there's a whole bunch of nothing. And that's still counted as your startup time. Why? Because that's the time. The startup time is when the system process and the activity manager received, hey, you need to start this application. And the activity manager is like, all right, I'm going to do this, I'm going to do that, a bunch of other things. Oh, by the way, start the app now. And so all that time is counted as part of like your Play Store startup, and it really is what the user is experiencing. But your code hasn't even started yet. Then in buying applications, your classes are loaded. The activity is created, started, resumed. Is this good enough? No, we haven't rendered the frame. The activity is not visible to the user yet. And then there's what we call a frame rendering, which means that your app will go through the view hierarchy. It's called a traversal, and there's going to be your usual measure, layout, draw inside on the main thread. And are we done yet? We're not exactly done yet, because on the main thread, when we draw, we don't actually draw. We record comments, and then these comments are sent to the render thread, the row you see below. And then that's the thing that writes to a bunch of surfaces and actually renders the pixels. So it's a lot more than just what we were measuring a second ago. What about trying to measure interaction latency? Like, how long did it take to tap this thing? Here I'm saying I have a button that shows a dialog. So in the onClick listener, I'm going to measure the time it takes to invoke show dialog, right? Is that the right way to measure it? Well, it turns out not really, because same kind of deal. So here we can see the top two rows are in the system server process. They're basically rows that are handling inputs, and then the bottom is the main thread. So here you can see there's input reader that's getting a signal, and then input dispatcher saying, oh, I got a touch event. Let me dispatch that to the application. And then the application, it's a queue of events, and the application eventually, the main thread is free, and the application look at that queue and it's like, oh, input some touch events. Let's deliver them. Action down, action up. That's the second chunk you see. Actually, on the action up, which is when the finger leaves the screen, there is no on-click code executed yet, because up on Android post a message to the main thread, and that message gets executed. So before that message gets executed here, you can see that we are rendering a frame of the button showing up in a press state. We still haven't invoked onClick. Rendering the frame with the press state, then onClick is involved. That's invoked. That's the second chunk here, which says view $, and it's perform click. And that's when your code is invoked. But the change that you make to the view hierarchy to show a dialog and everything, it's not visible yet. You just need to wait for the next frame and traversal, measure all of that to happen. And then it's measured. So it's hard. So measuring app startup, measuring interactions is tricky, right? Luckily for you, I figured it out with this library that is still very much in an alpha state. But basically, what I would recommend is to take a look at the code and get inspired from it. And it's a bunch of different hacks, to be honest, to try to measure the proper time that app startup took and the proper time that a click takes, including the tap handling and the rendering. And it looks something like this, where you just say, hey, tell me about these events. And it sends you an event with like the app launch happened, here's the data. And similarly, in an on-click listener, you would say, hey, I want to report that there was an on-click, or you could hook that up to your like navigation library. I'm not going to get into too many details here, but that's kind of like how we do custom production analytics at Square. So now let's talk a bit about reproducing and investigating issues. So assuming we know there's an issue and we can reproduce it, how do we investigate it? There's kind of two rules that are very, very important when you're trying to investigate an issue by reproducing it. Rule number one, keep it real. Don't use an emulator. Don't use a debug build. So real device, release profilable build, a real production account with real data. You can copy an account or whatever, but it's got to be real. Specific scenario that you have identified. The thing that you should never do is I'm going to start the app and plug in the profiler and tap around and see if I see anything on the profiler. Like, what are you doing? You should have a specific case that you're trying to reproduce and then look into, like, why is this happening? So that was the first rule, keep it real. The other rule is investigate outside in. So don't jump to the code. That's like a mistake that we all make. It's okay, but like, oh, there's a problem here. I know we did some changes last week. I think it's that, and you just jump on it. I'm just going to revert that commit. I knew they were doing something wrong, and then you move on. But you don't know, actually. The performance problems that we run into, they're very complex. There are many, many factors. So don't jump to the code. Start with the higher level signals, including maybe recording the screen and looking at the video slowly frame by frame to understand exactly what's happening. But really, the tool that I recommend today is Perfetto. So I have to ask, how many people here have used Perfetto? Okay, I see a few hands. That's great. When I used it the first time, I was confused. It was horrible. So many signals. I just closed the tab and went away. So I'm going to try to make that easier. So I usually use Perfetto, and once I have an idea of where the problem is, I use more advanced tracing techniques. And then eventually I look at the code, but it's mostly to learn about what's going on in the code. So recording a Perfetto trace, you just go on the perfetto.dev, they have a tutorial. I like the command line approach better than whatever the other options are. Just recommend it, but you don't have to do that. And then you go to ui.perfetto.dev. So let's look at an example here of a video where basically we're typing something and it takes a while for the thing to appear. So you couldn't see that, but this took like 2 seconds to provide a list of results from just typing one letter. And that's too much. So I'm going to try to do a quick Perfetto demo. And I've been going slower than I expected, so we'll do what we can. So let's see, I'm going to change to mirror, and then I'm going to switch to Perfetto. Right, so this is Perfetto, and this is a trace of the video that we were looking at. So we're typing, there's a letter coming in, and then we update the list. So when you look at Perfetto, and I try to zoom in to make it easier, so the UI gets a bit, like it's very busy right now. So what are we looking at? This is a timeline, time going from left to the right. And the first few rows are the CPUs. And so as with any, I have some notes, great, I should follow my notes. As with, that's too high level. You want to zoom in and see what's going on. You could use your mouse, but really the easiest way is it's like a gamer. You can use a WASD. It's the same keys as video games. And so you can zoom in. And what I love about Perfetto is that it's really, really fast. And that makes it really fun. So here, for example, I'm zooming in and you can see different apps. I don't see what's going on, but I just see that different apps have their different threads being scheduled on different CPUs over time. and or nothing gets scheduled sometimes. And so when you zoom out and see the whole picture, as you move your mouse around, if you hover on a specific thread, you're going to see all of the corresponding threads and processes with the same color. And so that sort of helps you understand who's taking a lot of time there. We get some more rows around CPU frequency, not super interesting. The thing that then gets interesting is you get one row per process. So I'm going to look into the process that I'm interested in here. And then, and that's the really cool part, you get to see some of what's going on. So for every thread, you have typically 1 or 2 rows. The first row is the thread state. So when it's blank, it means the thread is not doing anything. It's not scheduled. When it's dark green, it means the thread is running. Light green means the thread wants to run, but it's not currently scheduled on any CPU. And then I think there's like maybe yellow for I/O and red for uninterruptible sleep that is not I/O. And I'm not sure what that is. Maybe a lock or a binder call. And then the second row is something called, so in Android, you can do trace.begin section, trace.end sections. Those are called trace sections. You can log those in your app. And then that goes here, and it's visible here. And it's the stuff that you used to see with systrace. So here, I can zoom in, and one of the things that, so you'll see like, okay, there's a frame here, and there's a traversal and all that. One of the things that Papa, the library, adds, it's got an extension, like a dependency, that's going to magically add the class name of the runnable that's running on the main thread as a section. And that's useful because it tells you, oh, tell me, is something running on the main thread, and what's running exactly? Is it my code? Is it like Android's code? It's not perfect. You don't get full stack traces, but you at least get the class name just by adding that dependency. So here, if we were to try to look at what's going on, we can see that there is. So I'm gonna put a star on this. Oh, I'm not gonna put a star because we don't have enough space for this in terms of like screen size. But what's interesting is I also have some async sections that we've added around during the search for the list of entries. So you can see that the search happens over that period of time. And then I'm going to look for, so here I have an I/O thread that we used to make some I/O. And this says false because we logged false for whatever reason as the name of the trace. But what's interesting is that this is pretty much, I think this is like, the duration of this is 1.7 seconds. So I know that my search is taking 1.7 seconds, and that's why when I type, it's really slow to show the list. We're taking like almost 2 seconds. And so then I look at this, I'm like, oh, what's going on? And I can zoom in and start understanding, well, I see that the main thread, that thread, the I/O thread, is running a lot, but not all the time. I can see, and I can have data about how much it's running or not. And so this you have to know, but I know that this is making binder calls, and so calls to other processes. Turns out in this case, the other processes, this is just SQL queries. So what's going on here is that on this thread right here, we're making like 600 SQL queries. And that's why it was taking a lot. So, the fix is something like a join, where you stop doing an iteration over n entries and running a 600 SQL queries. One thing that's interesting, though, here is you notice how there's a space where nothing's happening. And don't worry about it, I don't need it. Nothing's happening, we're just doing nothing, and there's like increment disable thread count or something. What is that? Well, if you go elsewhere, you'll see, oh, at the same time, there's something called the heap task daemon doing work. That's the GC. And so this is basically the GC stopping the thread and saying, hold on, I need to clean up some stuff. And you can also see that because you can look at the memory on the same timeline, the heap somewhere, and somewhere in here, yes. And so you can see how it's been increasing, and then it drops after the GC is done. So this is super interesting. This is, I'm going to switch back to, because we don't have much time left. I'm going to switch back to this. But basically, this was a short intro to Perfetto, and I hope you use it because it's really cool. And I'm going to go back to this, and we have about 5 minutes left, right? All right. All right. So, so once you have that, you can look into other things like the memory profiler in Android Studio. You can capture a heap dump and investigate that. You can capture, stack traces or sample traces and try to like dive into the details. When you do that, it's really interesting to do like a flame chart to understand how much time is spent respectively in each area. Highly recommend doing that after you've done Perfetto. First of all, because one of the reasons is Android Studio is so slow, it's really annoying to use. Perfetto is fast, it's really exciting. So I just recommend that just because it's so exciting to use. But yeah, also start with like the bigger picture. And once you know, because what you're trying to answer here with Perfetto is, do I have an I/O problem? Do I have a CPU problem? Is this a lock? Is this a binary and interprocess call? Is this a GC problem? But if it's a GC problem, is it because I'm low on memory, or is it because I created a lot of objects? All of these questions you can answer with Perfetto, and then you can figure out the right next tool. Then you're going to write a test, right? And so this is where it gets interesting. So here, this was a short example. I don't have time to go into details, but it's an activity with Compose. Trust me, it's just a Compose activity. And we made a button that's showing a dialog, and then we added Papa in there to say this is a click that I care about. Now, what's interesting there is that I can then get production metrics. Like I'm going to report and track for like how long it takes to when I click that dialog. But also, it's going to create trace sections that are visible in Perfetto, which means that I can write a macro benchmark test. Because you probably didn't know that, but Jetpack macro benchmark actually uses Perfetto under the hood, captures a Perfetto trace, and reads its content. And that's the output you get. So then it makes it possible for me to write a macro benchmark test, run it, and get with the same line of code. I am both doing production tracking and also having a metric that I can build a macro benchmark test on top. And I can see it inside Perfetto. And so that's the pink section that clip captured is the pink block at the top, where what's happening here is that the actual delivery of the touch event, so the up event is the second pink top, like a little bit at the bottom. And you can see that we're starting the section a little bit after. So in terms of like what Papa does is the timestamp that we use is the beginning of that section, but we can't start the trace before we are actually invoked. So it starts kind of in the middle. One thing to notice here, I mentioned earlier, that's a bit of a detail, that the view framework posts a click. So when you do up, it doesn't actually start executing your code. Well, with Compose, big win, it actually starts doing the on-click immediately as soon as the up event is here. So that's a nice change. You could now claim Compose is actually more performant than the view framework. I don't know that it matters too much, but it's interesting. And then we go through the end, and then the trace and the time measured is at the end of that rendering. And so that's also what's reported in production. With that, that's it. Thank you for your time. I don't know if we have time for